Start streaming live from downtown Mill Bay. It's Saturday morning.
This is you, Phil?
Yo, what up?
Can I get another packet, but just...
You'll have to find one. I am going to be starting the lesson now, so you can check the top of my desk carefully. We did transcription last day. Today we're going to do translation. And a quick overview of the various parts that undergo translation in order to take in mRNA strand and turn it into protein. The mRNA leaves. Where is it leaving? Where was it made? It's made in the nucleus. And if you want to just get a piece of blank paper, you can write notes and then fill it in when you get your original back. To go to the, let's open up Class Dojo. I'm going to ask people at random. So my next question is, where's protein synthesis occur? What organelle? Gentlemen, shh. No, that's still loading. Yes?
The
No.
nucleus?
No,
No, the rough and the plastic.
So we got the rough ER. And then what is on the rough ER that makes it rough?
It's
Yes. Ribosomes. I'm really glad I bought a pencil sharpener. We have a new type of RNA, and that is tRNA, or transfer. Transfer RNA is what carries the amino acids into it. They have a little area here. Now you will notice that the transfer RNA in there is misspelled. So let me correct that. Custom color. Yeah, that sounds good. So let me, if you could correct the spelling of your tRNAs in here. Does anybody see what's wrong with them? The T's a capital, and the T must be lowercase. Horrors of everything. The reason being is we always do lowercase. This is the problem if you get a diagram that's made by someone who's not a biochemist. The lowercase is because it is not part of the acronym. It is indicating its function. So the T in tRNA shows it's for transfer, and the RNA is the acronym of the molecule to show that it's ribonucleic acid. And so it's actually, the capitalization is deliberate. Crazy people. Although I really like the diagram, and I can't diss the person who made this too much because I actually quite appreciate it. Here we go. So I will forgive them that one small thing. We have an area that codes. They match, if you notice, AAA here. That is known as a codon because it codes for a particular amino acid. In this case, for lysine. And where do I write the word codon? Remember, it's 3-letter segments, codons. And then the tRNA, to bring the correct one, has a matching. You may have a guess what we would call that. You have a codon and you have a, oh, I like that. It's close, you just reversed the wrong one. You have a codon and a anticodon. Just like you have pasta and the complete opposite of pasta, antipasta. Does anybody here eat antipasta? You know what I'm talking about? No, never mind. It's a reference that nobody gets. One codon codes for one amino acid. It's not actually antipasta. It's just that's what I thought it was for years when people have pronounced it. It's some sort of weird thing you put on crackers. And it usually has like olives and small onions and tuna for some random reason. Did you laugh at the existence of antipasta? A little, sure. What kind of base pairing is it called when you have U to A, U to A, C to G, U to A to U? It's also something nice you say to someone. I'll pick someone random. We're missing Liam Baker.
Yeah, where is Baker?
Noah Mitchell.
Tony.
Robotics. Same thing. You guys what?
Hmm?
Said what?
Everybody said what? What is it called when you have these two bases pair, U to A, A to U?
Complementary pairing.
Complementary pairing. Well done. They're like good roommates. They match, bond, and hold each other up. But they're not the same. Oh, I like that analogy. I might use that more often. The ternary matching base, I don't know what it says, based. It's based, man. Is called the anticodon. So, the function of the tRNA is to bring amino acids to the ribosome. It has an anticodon to match it, so it'll always have the right one, and it will only bring it to that specific code. A peptide is a small protein, one strand. Some proteins are made of multiple strands, and so when we refer to a peptide, it's the product of one gene. So you'll see peptide come up a lot. They just mean the protein that we made. So, which one is the actual coded message? mRNA or tRNA? Jamie. I caught you before you had to leave. Yes.
mRNA?
mRNA. Why?
Because it's the transcription.
Yeah, it's the product of transcription. It's the faithful copy. And the only reason I ask this question is some students will go like, but the anticodon also, yes, but it doesn't have it. It's following the instructions of the codons. It's just bringing them there 3 at a time. So RNA is the faithful copy. There is one other type of RNA, and it is rRNA. This is not writing. rRNA or rib. The ribosome is made of mostly protein, but it has a small RNA component called rRNA, and we think that's there to sort of help it stick. Its hydrogen bonds stick to the messenger RNA, not well, but enough to like hold it there a little bit, and so helps with the initiation and termination of everything, and it both helps it stick, and at the right point, it helps it unstick. Okay. Give you a minute to copy that down. I'm going to open up. Yeah. Don't accidentally hit things. What I would like you to do is turn over to the. Oh, is anybody still writing this down? I would like you to turn over to the next page and ignore everything you see here. You should have a blank page. Looks kind of like this. And divide your paper up mentally into 3 separate spots. You are going to be drawing 3 separate diagrams, roughly the same size. For the first diagram, but don't draw anything right now. In fact, don't draw anything, just look. We have that. Where's my little... Oh, there it is. Hey, how you doing? And we got that. And we need anything else? Not yet. Okay, so this is clearly what? DNA or RNA? RNA. No, it's not. How about it? Pardon? This is not mRNA.
There's a U.
In this?
Oh, yes.
Where?
Oh, is it supposed to be G?
Oh my God. That is a G, of course. So TAC, TAC, as in attack. This is the DNA. We make the mRNA from it. So here's, hello, I'm the mRNA. What process was that? Transcription. Now we're not doing transcription, so now we don't care, but now you know where it came from. And the DNA can go away. We're going to start with the process of initiation. With initiation, you have the mRNA, and these are both the ribosomes. So the ribosome, the large subunit, comes in and goes chunk, chunk, and attaches. The small subunit comes in and goes chunk, chunk, and attaches. And then we need, what other RNA comes in there? What's the one that carries amino acids? tRNA. What would be the anticodon for AUG? Not T. U. A. C. So let's go find our UAC. There it is. Let's bring it up with its amino acid. And it comes up. Chunk, chunk. And so now we have our protein, methionine. And now you also know what protein it is. I could have asked you. You don't know that you know, but you know. Something you probably didn't expect me to say after chemistry was done. Please get out your data table and turn to the biology page. And honestly, I may have said that the periodic table was the most important part of the table. I was lying to you. This back page is the most important table on your data table. Why? Bye. We'll miss you. She didn't even turn around. She's just walking away. It's too sad. She's probably crying because she's missing us. Okay, back table. Why is this the most important? This is the most important table in the world. Look at why this is the most important table in the world. People have searched for this for thousands of years. When people ask, what is the instructions of life? This is literally it. It takes the instructions of life and turns it into stuff that does something. It turns out the instructions of life are just like make protein. So, we look at this. Can you find AUG on this? Find it. What is the code for?
Wait, what is it?
AUG.
I just have isoleucine.
No.
Oh, sorry. Methionine.
Oh,
Methionine.
meth-
I like the everybody in every class is so far. I said methionine or something of that effect. And it's methionine. You'll pronounce all of them wrong, and that will be greatly amusing for me. So you go to the first base here, A. Then the second base, U. So you know which box you're in. And you just look it up. A-U-G. There. Methionine. Also, it has a little star next to it. What does that star mean? Read it down here. It's got a little star. Read it on your table.
It's an indicator codon.
It's an indicator codon. every single amino acid starts with methionine because AUG is the start codon. Now, could you get an AUG somewhere in the middle? Yes, it's not always the start codon, but it is always at the beginning. So it's either methionine or it's methionine and the start. You don't start with any other amino acids. So this is the start codon. This is mRNA. This is the tRNA. That's the anticodon. No, you're not writing this down. You're just looking. You're just looking. I don't want you're not, I promise you don't have to write this down. Anticodon, tRNA, it comes in, there's literally, I draw it like this because there's literally a hole for it to go into, and it sits there. Obviously we're going to have something else go on. That I can't even read myself. Start codon. Now, is this table a codon table or an anticodon table? Read the title. It's a codon table. So you will be given codes and it will say, what amino acid is this code for? If it's DNA, you've got to transcribe it over to the mRNA and then look it up. If you're given the anticodon, you then have to figure out the codon and look it up. Or you'll be given both. You have to pick the right one. This is a codon table. So you cannot look it up with the anticodon. You'll get the wrong amino acid. This is called initiation. So at initiation, the mRNA has moved to the cytoplasm. A ribosome has found it. The initial tRNA has stuck to it, attaches to it in the ribosome, and now it's ready to go. This is initiation. Everything sort of clicks together. Chung, 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 chung. Excellent. Now you can write this down.
Wow.
The whole diagram. I want to be able to explain it without everybody writing and not hearing things.
You can't tell us you right now.
You can't what?
You just write exactly what's right.
Yeah, you just write it what it is. And you can also ask some questions like, what does that say? But obviously, it's so easy to read. No one would ever do that. That's also a T, not an F. Yes.
The whole thing, like the hat and the model thing, that's a ribosome.
Yes. So, oh, I should label this. I meant to label this. Thank you for reminding me. This is the large subunit,
Of the ribosome.
and this is the small subunit. Subunit. And they were both, I don't know what they indicate. I'm just going to write of ribosome beside each one. So ribosome is actually composed of two parts. Well, it's not that weird. I do know someone who takes off both their legs before they go to bed. So they have 3 units. They're 2 artificial legs.
3 units?
Yeah, so there's their one leg, their second, so they have 2 smaller subunits and 1 large subunit.
Oh.
Did you label the RNA?
Nope, if I was to put rRNA in there, I'd probably do something like this.
Oh, it's just like a.
It's just like a little bit of it. It's somewhere in there. We don't have to worry about it too much, but there is a little bit of rRNA in there.
That helps to stick.
Mm-hmm.
Do we really know that's what it does, or are we just kind of guessing?
No, that's all it does. and we know that for a fact.
No sense.
And we're not going to discuss it any further.
So you're lying.
I would never lie. I've never lied in the history of the universe, and I've also never been wrong.
Sure.
Yeah. Right? Excellent. See? Their grade just went up. Well done. Okay, is everybody done with this diagram? That's disappointing. I should probably do it today, given.
So like,
So Aiden is here, Arnie
Aiden is
Yeah.
is here, and Bo is here, and Graham is not, and Grayson
Grayson's not here.
and Jamie just left.
When is Grayson moved out?
So should I mark Jamie as here or not here? Probably not here. Layla and where's Liam Baker?
apparently he's at a robotics tournament.
Lies. Murray is here, and Matthew
Robotics is fun.
Miyabi, and Nick is here, and Noah Mitchell is here, and Rachel, and Rose.
Nick is also at robotics.
She's not sure.
I don't see a Rose. Yeah. Hold it. I saw a Rose.
Rose is in the washroom.
Oh, okay. I was like, how did that happen? And then Violet and yes.
So this will like a ribosome like go down it, or will like?
Oh no, I'm not answering that question. Yep. Is everybody done drawing?
We,
Wait, sorry, what's the code? Where's the code? Or it's not.
These are the codons in groups of 3. Any other questions? Is everybody done drawing?
Oh wait.
That's it.
Hold on.
Large.
Subunit.
Subnet. Yeah.
Subunit.
Subunit.
Not subnet. That's like a
I
computer
can't really
thing.
see what that says. Like,
But I just
like below-
hold it.
Yeah, what
Where's
is
your
it?
glasses?
No, I can see the
No,
letters.
where's
It's
your glasses?
SU,
Lies.
SU, like that looks like a B.
Yeah, I can't see
Or an
it.
A.
No, no,
Looks like
no.
an A is
Here,
better.
I'll prove it.
No one can understand.
It's not the top of my eyesight.
It's totally your eyesight.
It's the right.
Everybody else can see it. Everybody
What does
else,
it say?
everybody else, just to be clear, your grade depends on this. Hands up if you can see it perfectly, knowing that your grade depends on it.
Only Bowen, yeah.
Okay, your grades went back down. Only Bowen's went back up. Okay, fine. Oh,
Okay, thank you.
yeah. The computer could read it.
Oh. Wait, I actually got
I've
it.
tested it. No, leave it
Wait,
where it
look.
was. Leave it the way it
I don't know. Smell.
Oh, it made the E little and above separately.
Smells so
That's hilarious. I will leave that there. Okay. Is everybody done? Okay, good. Anybody not done? That's a better way to ask the question. Okay. Now, put your pens and pencils down then, because I'm going to delete a bunch of stuff and I don't want you to draw it. Because we don't need you already know now what the codon and anticodon are. You don't need them for the future because you've already labeled them on the first diagram. I'm going to delete them because I'm going to redraw it in the same spot rather than going to different spots. Okay, so we have initiation, and we've already now done it. So initiation, go away. Go away. Go away.
You've been initiated.
We have been initiated. Now, what happens? What anticodon would fit GGC? Gentlemen, focus. Aiden, what anticodon would attach to GGC? No, don't look at that.
Oh, is that how it is?
No, I didn't ask for the amino acid. That's the next question, though, so you could prep. Aiden,
Yeah.
what anticodon attaches to GGC?
CCG.
Nicely done.
Yeah.
So, CCG. Oh, and what amino acid should be attached to CCG?
Oh, CC.
There's a pattern to the table.
Okay.
First base here. Second base along there.
Proline.
Proline. Let's see if you're right. So, CCG is not proline, it's glycine. So what mistake did you make? Yeah. You looked up the anticodon, because I said what amino acid goes on that, and you look it up on the table according to the codon, not the anticodon. Look up, everybody look up GGC, confirm. Is it glycine? G.
You said CCG.
Yes, for the anticodon. I fooled you. G, not on purpose, but G, G,
Oh, so
C
it's GGC.
is glycine, right there. Yeah. And remember, this road here is first base, easy to find, then second base, and then you have to go to the thing for third base. As they say, it's always easy to get to first base.
Why are they all glycine?
Why are they all glycine?
Like everything in.
Ooh, I'll address that afterwards. Okay,
Okay.
next. Watching, not writing. We form a bond between the amino acids. That is called a peptide bond.
Okay.
Not writing things down. What are you doing? Stop it. No. And then it goes, this tRNA floats away, leaving the amino acid behind. This goes chunk, chunk. And then we bring in the next one. What anticodon would fit GAU?
C.
No, hands. Yes. Hands. And you both have done one. You there? Yes, I don't think I've done one. Pardon? CUN. CUA. So let's find CUA. There it is. And I was going to ask someone for what the amino acid was, but it turns out it's aspartame. So CUA comes in. Chunk, chunk. Oops. Come on. I need more chunking. There we go. And then, guess what forms in between them?
Peptide bond.
Peptide bond. Oh, so what the heck happened here? Our small subunit went away up there. And then guess what happens?
Repeat.
Oh, jog, jog, it moves over. This one goes away. So this is a process known as, grab it, elongation. Elongation. Where should I put elongation? Put it there. Put it there. We have room there. No. Let's put it here. Aha, perfect. Fits there. So elongation. tRNA binds to the anticodon to the codon. The amino acids form a peptide bond. The ribosome moves one codon over. tRNA detaches once the peptide bond is formed. And then you repeat, and you repeat, and you repeat until stop. Now write down that whole diagram separately from the other diagram. I remember at the beginning when I said make 3 equally balanced spots. Get a separate piece of paper right below it. Like that big red thing in the middle, you can just go below that. And then this one goes chong chong. Whee! I'll put it there because it's in the process of going. Or there. Maybe make that one closer. Show movement. A peptide bond. Why are you? We never did the peptide bond, Mr. Neufeld, and I'm just going to say it's a special. Covalent bond. And the only reason I mention it is because it's a magic word. You're going to learn it if you do anything to do with protein synthesis in Bio 11 or Bio 12. And it's special chemically because an amino acid, and I'm just going to do this while you're drawing. You don't have to write any of this down. Looks like this. So that is a single amino acid. I write R, not because it's R, but that's the part that changes. There's like 20-ish different things that could be. All of them give it different properties. And if you put two amino acids next to each other and you bond them, this is primarily of interest if you're planning to go on in biology or chemistry, or you just think knowing the meaning of life is cool, is you then take, oh, that's supposed to be an OH. My thing did not write properly. That should be an OH, and that should be an OH. Is that this OH and that H come together? What is HHO? Water, H2O. This, oh. So water comes out, and that hydrogen flips to the other side, and you get a bond between them, and then it's special because all these extra electrons go like this, and you actually get like 1.5 bonds on both. Again, you don't have to put anything on your diagram, but it means it doesn't bend. All of these can rotate except for that one, and it adds some stability, and it has consequences for folding proteins, which is what the next stage would be. And so it's a really important bond. It's the second most important bond.
You're not getting us this time.
Come on, somebody ask. It's the second most important bond.
What's the most important bond?
James Bond!
That was a good one.
Yeah. I make that joke every time. For every type of bond.
Yeah, that's good.
Maybe it's disrespectful. Because James Bond needs more respect. I did name my child after James Bond, so. Kirk Gellin, Apollo, Tiberius, James Thor, Bond, Ronald, Eric, Mayfeld, Hanley. Yes?
What happens to this when like the mRNA stops? Like to the
We haven't done that. I'm not going to tell you.
Okay.
We've done initiation. We've done elongation. What would you guess the next diagram will be?
like
Stop.
Stop.
Except we get fancy and we call it termination.
I am too. I really draw it.
Because I think it destroys itself, right?
No, it doesn't. It can all just keep being remade. In fact, this is often a longer piece of mRNA. While this is going on, another ribosome can come in once there's room and start, and you can get multiple of them reading the same mRNA strand. The mRNA strand is done when it wears out. It literally wears out. Okay, anybody still drawing this? Good? Rachel, good? You look like you're right. Are you right? If you're still ready, I'm going to wait. But also not going to say anything. Good? Honestly? Okay. So, Aiden, also get glasses. Okay, I'm going to take away the peptide bond because, like, now that you know what it is, who cares? Let's just do that. And we take away this. So this goes away, moves. Take away that, who cares? This moves over. Chunk. What matches? Look up your codon table. What is the anti-codon for GGG? CCC. And not, to try and not confuse you, what does GGG code for? Lysine again. It is good guy Greg. GGG. Whereas, oh, there it is. So, do you guys even know good guy Greg? Do the memes exist? We'll never know. Ching. Gentlemen, focus. Not a buzz. It makes me sad. Moves over. Oh, what did I forget? Peptide bond formed,
And float away.
and then this has to float away, and then this has to move over. Chunk. What is the anticodon for UAG? AUC. Now look up what amino acid will be carried by UAG.
Stop.
Right. Stop. Is there an amino acid that's carried by it? No. Like methionine is always the first one. Even though it's AUG and even though it's a start, it does carry an amino acid. You can find AUG somewhere in the middle. But if it hits UAG, that just means stop. It means, look, I had a picture. Stop. In the name of love. And at that point, when it hits this disrupts the bonding, and this floats away, and this floats away, and that floats away, and that floats away, and you get left with the protein strand that can now be an enzyme. It may be taken by the endoplasmic reticulum to the Golgi apparatus, packaged and exported outside the cell. If it's like insulin and it's a hormone. If it's used for muscle, it'll now immediately be used inside the cell to be some of the structure of that muscle cell. And so now you have made the protein, the stop codon has happened, everything detaches and can be recycled. So the mRNA is going to get a new ribosome, that ribosome is going to find a new mRNA, and all the anticodons, tRNAs, are going to go pick up their appropriate amino acids to get ready for their job.
Oh, they repeat.
And it just repeats.
Okay.
So this phase is called termination. I should have, oh, my references, I didn't think to get Arnie in here. I could have done this whole thing with an Arnold Schwarzenegger accent. It's termination. Termination. Now, how many stop codons are there in your table? 3. They actually have names, amber, ochre, and umber, which I just love because when scientists get bored, they do have poetic souls and they name them after colors. I think your table might just give them as stop, but other tables will actually give them by their name because it sometimes matters in terms of mutation which one it is. So termination, the ribosome hits the stop codon, the ribosome detaches from the mRNA, the tRNAs detach from the amino acids, the peptide/protein is left as a chain of connected amino acids, a protein polymer. So initiation is the largest phase. You have start, and then everything comes together, and then elongation, 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 and then just stop.
Are we drawing?
Yes, now draw it. Draw all of this.
Which definitely makes sense.
How could I look up things while you're drawing it?
Can you freeze
Don't-
the screen?
No, I used to have a projector I could draw on rather than the TV, and it had a special function where I could say freeze, and then it would just keep displaying what was on there, but I could do anything else in behind and you wouldn't see it. And this doesn't have that. But it's not an important thing. I was going to go get a picture of the Terminator for termination. I still have Evan Ross's headphone charger. Oh well. He wasn't cleaning his room fast enough this morning. He told me he'd die without his music. I think that's a worthwhile experiment. Will he die? Will he not die? Will he merely be horribly maimed?
I feel like that's a great way to get removed as a house parent.
Well, I did pick up Gleb.
What?
Gleb, spinach. I believe it was in a house meeting near the end of the year last year, and I said, "You failed your room, we gotta go clean it." And then he said, "Yeah,
Well, I think
who's gonna make
I
me?"
think I saw the video.
So I picked him up. I also told everybody not to spread the video, so immediately everybody spread the video.
Yeah. That was really cool, Mr.
Gleb was fairly strong. I think the only reason I got away with anything is because he was laughing so hard he couldn't do anything about it.
So you got in trouble.
No.
Faces
I wouldn't do that to someone who I didn't know well and would take it badly. I knew Gleb well enough that he would find it funny.
But you did have to go.
I mean, I did.
Yeah.
Right? This is being recorded, so hypothetically this didn't happen. But like Evan wasn't getting up, so just crawl into bed
Where did you?
and keep poking him until he wakes up.
Oh, I'm sorry.
Did he clean his room afterwards?
Yeah, I think so. I think they passed. Is everybody done with this? Excellent. What time does this class end? In 3 minutes. Okay. To give you then a heads up for next day, I have posted a computer program that I would like you to download and install on your computer. There's both a Mac version and a Windows version. It does not have an app because there's too many calculations. Have you ever played that game where you do it's not Tetris, but you put blocks in places? Yeah. It's not Block Blast. It's not made to be addictive. On the other hand, the gameplay kind of reminds me of that if you go through the tutorials. You're moving things around. Because the part that this doesn't talk about is once it's made, we're done. Science 10 is done. But there's a huge... Why are you packing up? The bell hasn't gone. That's very nice. Just calm, it's fine. Just calm it down. Put it down on the table. Table. The next phase that happen is this actually has to be folded. And that part of the process we can't always figure out. And sometimes proteins, we know the genes for it, but we don't know its shape. And we knew its shape, we could invent better cancer drugs, we could invent better vaccines. There's a whole bunch of things that if we know how this folded. What this game does is you take a protein and you fold it. And it gives you a high score because it calculates its efficiency. The people who made the game won a Nobel Prize because once you're done the tutorials and the easy proteins, they give you proteins they genuinely don't know how to fold. And then thousands of people just try to fold them. And some of them get better high scores than computers who try and calculate the best ones. Because a lot of it's just trial and error. And if you get a better score, you will have figured out a better way of folding it. And so it's also a good way of teaching that. Next day, we're going to do an activity involving scissors and pieces of paper. And you're going to mimic this translation. And then when you're done, I'd like you to try the folding game. If you have it pre-installed, it will just make that a little bit easier. Does that make sense? Okay? The game is officially assigned, so if you love it so much, you can claim you can do it during prep. It says right on the assignment in the Google Classroom, yes, duty person, this is for prep. You'd like to prove it.
I think, only if I did prep